A great delusional error is found in the famous double slit experiment, a new foundation to work upon, a link to unify physics, for light photons only. Particle physicists assume there must be particles because waves can only pass through another. Here we will find that is not always the case. The double slit ends up with spooky, unreal concepts like the universe only exists as a product of our consciousness, multi-universes, and how a cat in a box is both dead and alive. A superposition duality illusions results in misinterpretations and delusion. The double slit demonstrates a limitation of the ability of the observer to predict experimental results. Richard Feynman called it a phenomenon which is impossible to explain in any classical way. It contains the only mystery of quantum mechanics. Blunder in double slit experiment. Misinterpretation of duality. Groundbreaking work for a new interpretation of the double slit experiment. The concept of duality got on the wrong track at the time of the Copenhagen interpretation in the late 1920s, resulting in conclusions of unreality. This disclosure redefines superposition and interference in such a way which corrects the conclusions that result in illogical unreality concepts. The key point in this article is what would cause the intensity to become 4 times greater during the constructive interference of light. In nearly all the explanations today, the intensity is left out, is important, and should be included in all presentations of the single and double slit. When the intensity is evaluated during the assembling or forming of the slit, the terms describing interference such as constructive, destructive, or annihilation become not only misleading but incorrect. Instead, light impinges or collides at the slit, redirecting and fanning out into the interference pattern. We're going to prove that today. Physicists have worked out through mathematics ways to explain the 4 times intensity. However, it is unreal. The intensity adding to 4 is known already, but no one has taken the time to fully analyze how and why. The human mind is confused and blocked by the concept of superposition, where waves always pass directly through another. If you look closer at this step by step, you will arrive at the correct conclusion, and the weird mysteries of the double slit will dissolve away. Without this new concept presenting here, the double slit is, as Richard Feynman stated, a phenomenon which is impossible. It's all based on an error that should never have happened. It's not something that can be solved by sitting in a chair at a desk cranking out numbers. You must get your head and hands into something more concrete. Realism has replaced reality with the double slit experiment, and all kinds of philosophical, illogical arguments have arisen. Realism and reality are different concepts. The theory for the double slit has realism, meaning that concepts exist independently of the observer. Bear with me a little further. How can all these weird unreality concepts come from the double slit? Examples of unreality conditions arriving from the double slit all can be debunked. Google double slit to see how many unreal, nonsense, illogical arguments and ideas came to be. Where did it go wrong? Let's put the double slit back on track. Starting with single edges, let's break it down into sections to see where it went wrong. Okay, on the right is the resulting line from a laser beam striking the left edge of a razor blade. Here it's hit the left edge, and this will be a slit when we close it. Okay, and below is a similar line from the right edge only. So we only got the right edge only. Okay, now we're going to combine the 2 lines together by closing the slit and making a single slit. Okay, so now we place the two lines on top of each other, just as I said. The two edges are simply placed side by side. That puts the two lines on top of each other. Okay, 4 times brighter. The two lines try to go over another, but they cannot, and a pattern of dashes is formed instead. Common sense would say that the brightness of a fringe would simply double. Instead, we get 4 times the intensity and dark spaces. Present theory answers this in an unrealistic way. Logic would say that the missing light from the dark fringe has moved into the bright fringe, increasing the intensity to 4, not 2. The only realistic answer is the two lines have collided and found new paths. The waves can only collide once unless they again strike another edge. EM waves can appear to be particles because they can either collide or pass through another. Superposition has another attribute we have been overlooking. The concept applies to the double slit as well. It's not a wave appearing somehow to be a particle, but waves that collide. The collision of two waves makes a photon appear like a particle. Because superposition infers that two waves always pass through each other, they should never appear as particles. But if somehow one could get two waves to collide, they would temporarily appear to have the attributes of two solid objects colliding. Thus the experiment can be altered to either collide or pass directly through another. Varying the experiment turns the collisions on or off. This is how people are fooled into duality. In reality, the two waves can either collide or pass through depending on the circumstances. Photons are only waves that can be forced to collide like particles. They're only temporarily appearing like particles. Without this understanding, wild, unreal concepts develop. It's a simple fix, and the math to calculate the interference pattern still works. The photoelectric effect. This short disclosure suggests that a wave can knock an electron out of material. Particles are not required. There is still a quantum effect, but there are only waves, which some errantly believe the waves are particles too. The photoelectric effect does not need particles. A wave can do the same thing. The photoelectric effect does not need to support the particle theory of light. Wave-to-wave collisions takes its place. Conclusion: we have been deluded by an illusion. In another video, photons are forced to collide head-on and shown to directly bounce apart. This is important. A precisely aligned Michelson-Morley interferometer, when the legs are precisely adjusted at D1 equals D2, and this is a very difficult precision alignment, reveals a head-on collision of light waves. The light has an absolute total head-on collision where no light reaches the screen and all the energy bounces back into the laser. A blackout at the screen occurs. Okay, I have that video on my webpage. There are differences when the medium changes from water to photons and then to electrons. Unlike photons which collide in waterways, the water from the destructive region sloshes into the constructive regions. That could be written better. Okay, regarding electrons, a revision is required for the electron, which appears to be a particle that leaves a wake. The wake is on a field that was rejected over 100 years ago. These conclusions cannot be directly arrived at solely through mathematics. and experimental history and all corresponding accepted and rejected ideas must be reevaluated. A maze, something that was not possible before this time. Interference is a natural phenomenon happening all the time at every edge, even with white light. See the white light in, okay. I have an associate degree in engineering, and this does not require rocket science to figure out. Okay. Please respect my long labors on this endeavor. The professors teach their students, and the students ask questions. The questions of the students plant thoughts in their professors' minds, which the professors build upon and get the credit. We're all students. Okay, what I'm going to point out here now is, here's what's presently going on with how they calculate the path. It's done by path length difference. When it's destructive, the path length difference to the screen is calculated as a destructive point. Instead, and that comes up with the correct answer, of course, but instead there's collisions between the slit, and that causes a redirection of the photons. Okay, over here is this is a white light interference, and this is a paper box, and in here we have a slit, and that's just a paper box. Okay, here's what happens when you pass white light through it. I hope this thing could be shown better. Okay, now here we have that's the paper box I showed you right here. Okay, just a piece of paper, and that's how big the groove is. Okay, and it's sitting on top of a cardboard box case. Okay, the white light, incandescent, and here's the shadow. And right here is an interference pattern, and it shows both. This is just white light. There's a collision occurring in here of the light photons, and the path is redirected, and you get an interference pattern right there. You can see a dark edges, bright and dark edges. Also, we got a similar thing with a razor blade. There's a lot. This is laser, lens, a razor blade, and the screen. A present theory explains the pattern by the path length difference. So when you measure the difference between one point to the other, if it's off by a half wave, it's destructive interference. And so the wavelets are coming in from this side, and they're more or less curved and out, not totally lined up. When they hit the barrier, it flattens out. The last one flattens out, and they squeeze together and elastically bounce apart. And they shoot out, redistribute, and fan out into the pattern. That's this impinged theory I'm explaining. Okay, if it was the present theory, you would have interference. You would show something in between here, the positive and negative, as they interfere. Okay, instead, you end up with a pattern like this. This is the pattern. That's the horizontal pattern. That's this one here going this direction. I cut off this part of it, only the end. Here's the setup. You could look up, there's several versions of this fanning out. And that's the interference pattern on the wall. And this is a horizontal. layout of it. So this is the plate. I cut off the center section because it's too bright. Okay, this is with the room lights on. Now we got the interference is on the wall. There's a flat plate, and this flat plate is this image right here. This is the flat plate. Okay, this is actually reflection off the flat plate. This is actually the pattern right here. That one right there, the long one. Okay, this is horizontal to the beam. There's nothing no pattern in here like you see with water waves. Okay, and you can also take a piece of tape, a long piece of tape, I have a video of that, and run it between these two all the way to the slit, and it doesn't affect this. It doesn't affect the pattern. So nothing's crossing across these areas, the dark areas. Nothing's crossing across the dark area. So there's something wrong with the current theory. Here's the apparatus for splitting the laser beam in half, the interference pattern in half, like this photograph shows. There's the tape. Okay, here's it's a green diode. I'm splitting a wire, but the double slit makes no difference. I checked it already. Okay, and then here's the tape. Okay, the room's a little messy, but it's just a long board. It's like, there's the tape. And that splits the beam, the interference pattern, and I got a photograph of it. Okay, that's the screen. I don't know if you can see the pattern's already been photographed. Okay. Okay, that's the that's all there is to it. Long board, it's like 16 feet long, plus about 3.5 feet. The splitting part's 16 feet long, so it can't get to either side of this piece of tape. So it invalidates this drawing because the tape separates the two interference fringes. So it points to wave collisions at the obstacle. Second beam splitter for the second screen. There is a second screen. No one shows the second screen, but it should be on there. And what it is, it's right here. That's the second screen, and it's located just the laser, the light goes through the pinhole or through the hole, and then it's normal for the light to hit the mirror, both mirrors, and reflect back. If you look at the mirrors, that's what's going to happen. The light's going to end up going back to the source. Okay, this is normal for the light to go back to the source. However, what is unusual at the second screen is that the fringes are the reverse or negative of the main screen. So right here I have the main screen. That's the main screen. And over here I have the second screen. That, if you look closely, the images are reversed. Now I'll try to get a black spot in the center. That's about as dark as it's going to get. Okay, now I have a bright spot in the center over here. So they're reversed. Okay, when the interferometer is critically aligned with only one circular spot appearing at the main screen, as found in the MIT video, Where Did the Light Go? Here's the reference for it. I'm going to insert the video in here now.
The left on the screen then is associated with the light that's returning to the source. The spot on the right is the spot that we looked at before. That's the one that's coming through this lens, and then we've added
Okay, in the MIT video's case, the photons have hit absolutely directly head on. Only in this case, all the light has managed to bounce directly back to the source, and the main output screen becomes totally dark. This proves there are collisions in effect. This only occurs with absolute precise alignment, which I am unable to attain here. So you have to watch the MI2 video.
Welcome to In Depth with Academia. I'm Richard Price, founder and CEO of Academia.edu, and I'm really happy you're joining me today as we take a curious dive into some recent academic work. Remember, I'm presenting this research neutrally, as always. My goal is to break it down in a friendly way so you can absorb the core ideas and, well, see what you think. So the focus today is a recent paper by Todd W. Grigsby called Formal Protest Against the Concept of Duality and the Superposition of Light Waves. That's a mouthful, right? But hang with me. This paper raises some striking questions about maybe one of the most foundational ideas in physics. Let's set the stage. Have you ever wondered about the double slit experiment, the one where light behaves like both a wave and a particle, depending how you look at it? It's this mind-bending thing where if you send light through two slits, you get an interference pattern, but try to peek at which slit the light went through and the pattern disappears. Everyone says this is quantum weirdness at its finest. But what causes that weirdness? Why do we talk about waves and particles at the same time? Is superposition, where waves are supposed to just add up like water ripples, really what's happening? The paper's core question is right here. Is it correct to say light superposes like water waves? Or is there something deeper, or, dare I say, something we got wrong over the last century? Why does this matter? Well, I'd put it like this. How we think about light, whether it's a wave, a particle, or some weird in-between, is tied to pretty much everything in quantum mechanics. If a mistake crept in, the consequences would be huge. It could affect, from how we build lasers to our fundamental explanations of the universe. Okay, so let's jump in. Grigsby's main argument is that the idea of superposition, borrowed from water wave experiments, was applied to light in a way that's out of place. He says that light waves, in fact, don't superimpose at all. Instead, they collide or impinge on one another. Kind of like, you ready for this? A bunch of tiny, flexible dumbbells. Seriously, the paper is all about this replacement idea called the impingement theory, where photons, instead of being smooth waves that pass through each other, are these dipole-shaped, dumbbell-like things that can bump, spin, bunch up, or squeeze through slits. Based on their alignments, you actually get two basic types of collisions. One that lets them sort of spin around each other, seeming to pass through, and another where they bunch up and create patterns, like we see in the double slit experiment. And here's the fun part. This dumbbell model is supposed to explain why sometimes light looks like a wave, sometimes a particle. It's all about how these dumbbells interact. Sometimes they align and collide to create that interference pattern, and sometimes they misalign and just pass through each other. So what about superposition? According to Grigsby, the whole superposition business, the idea that light waves can just add up constructively and destructively, like ripples in a pond, is an illusion caused by the collisions of these dipoles at the slit. The interference pattern, he argues, actually forms right at the slit, not on the screen meters away. This means that after that, the strands of light don't interact anymore and just head to the screen on their own. He backs this up by citing edge diffraction experiments, the famous double slit setup with barriers, and some surprisingly simple things you can try at home, like shining a laser pointer at a hair's thin wire and seeing the pattern that emerges. He suggests that these patterns are more about impingements than anything to do with waves adding up. Now, don't get me wrong. I'm not endorsing or rejecting this. I just think it's really wild to see someone push so hard against such a foundational idea. The paper's tone is almost a call to arms, saying that physics took a wrong turn and that a new paradigm is needed. Of course, this is one perspective. Physics is full of deep debates, and theories can stand or fall as new experiments come in. What does this mean for you, the listener? Well, first, it's a reminder to take nothing on faith, even if it's taught in textbooks. Ask why things are the way they are. Second, if you're interested in quantum physics or even just the nature of light, this is a chance to dig deeper than the surface and see that, hey, even world-renowned topics like wave-particle duality aren't set in stone. Oh, and actually, speaking of textbooks, I remember once in college, my physics professor confidently drew overlapping sin waves on the board, talking about superposition, but then admitted later, honestly, no one truly knows what a photon is. That stuck with me. Anyway, bit of a random memory. Sorry for the tangent. One last thing. Academic research is about asking questions. Sometimes it overturns what we think we know, but it's never the final word. It's a journey of curiosity. So, whether you think the impingement theory is it or not, I encourage you, let ideas like this inspire you to experiment, to ask, to never stop wondering about what's behind even the most familiar science. I'm Richard Price. Thanks so much for listening to In Depth with Academia, and until next time, keep questioning everything.